Hey, what's up guys? Look at me, I got another video coming. This video is going to be about these stupid things. If you know what this thing is, I'm sorry. This is the green connector from the RAMPS boards that the 3D printers use. At least the ones that the Folger Tech kits come with. There's plenty of other open source 3D printers, or even not open source, I believe, that use the RAMPS board. If you use the RAMPS board, this is the input power connector, basically. I'll put a picture right now of this, being connected on the RAMPS board or something. I'll find something. I don't have a RAMPS board to display right now, unfortunately. But basically, the problem with this little thing is its power rating is not that high compared to what the power draw is. This is rated for 20 amps, it says. 300 volts, 20 amps. But the printer itself can draw quite a large number of, quite a high number of amps through the bed and through the extruder, plus the motors and everything else. So what I actually see commonly, especially on like the different 3D printer groups or the Folger Tech group, anything like that, is this will melt. Either the edge or something like that will melt for people if they don't wire it correctly. So basically, it'll be resistance happens, or something like that, which leads to heat, which leads to melting plastic, which leads to fire or smoke or something like that. So this video is going to be how to avoid that and how to properly wire this thing. So although I've finished making this video, I need to preface it to cover my butt. I am not responsible if you screw anything up. I'm not responsible if you do this wrong and blow up stuff. I'm not responsible if this catches on fire anyway. I'm not responsible for anything. You do this at your own risk, blah, blah, blah. Folger Tech is also not responsible for any of this stuff. Folger Tech is my employer, but they are not responsible for anything that I do on this YouTube channel. So it's not their fault. It's not my fault. If you screw something up and you catch things on fire or something gets damaged, this is just a how to connect this thing correctly, how to not screw up the wires and not catch things on fire, okay? Thank you. Continue with the video. So the first thing I see happen usually is people will just strip the wire with strippers, automatic strippers, regular wire strippers, even some other, just scissors or something like that. And they'll just take the bare wire and just shove it straight in there, right? Yeah, don't do that. Please, come on, don't do that. That is a great way to electrocute yourself, catch this thing on fire, catch your house on fire, catch your children on fire, catch your dog on fire, and I'm sure most of us care about those things, so you don't want to catch them on fire, okay? Whenever you strip down some of this wire right here, you need to insert it right into these holes. It'll depend on which one it is. 2 of these are positive, 2 are negative, etc. But you need to put them into these holes and then tighten down on these screws, and there you go. But here's the thing, you really want this to be tight and tinned. That is the biggest thing people don't do, is they don't tin the ends. You can strip this all you want, you can even twist it all you want, but as soon as you go to insert it in there, it doesn't matter how tight you have it. You can try to push and you just want to get it in there because you really want the printer to be fired up soon, and you get it in and you just tighten it down and everything's good, right? It looks perfect, but look at that. That causes fires. This causes bad things to occur. Oh my god, I'm disoriented. Like the monitor that I'm looking at is upside down and it's throwing me off. Anyway, shit like this is bad, okay? Basically, that's what's going on. And if you have that shoved in there and a wire gets loose and touches one from next to it and words and stuff, if this happens and this is a negative and the same thing happens to the wire next to it and it's positive, you're going to get shorting. When you get shorting, you get bad things happening. Okay, so strip the wire, twist the wire, make sure everything's nice and tight. Come on, focus. Look at that. See? You want it tight, and then you want to tin the ends.
Now hold on there, Dustin. You just told me to tin the end of the wires that are going into a screw connector. You see, in the industry, we don't do that. That is against code in some applications, and it's really not recommended. For those of you saying that, you are basically 100% correct. It is industry standard to not tin the wires that are going into a screw connector or any sort of clamping connector like this. Another example would be the wires that go onto the 12 volt out of the power supply. You really don't need to tin the wires for that. However, I do. And basically that's where I'm going to leave you at this stage of the thing. From here on, or the rest of this video is basically going to be me showing you how to tin the wires and how to install it correctly with the wires tinned. You do not necessarily need to tin the wires like I'm showing you. I prefer doing it that way. I have never had an issue that way. I don't really know anybody who has had an issue doing it this way. But the industry will tell you that this is a bad application to do tinning the wires, basically. The idea is if you tin the wires, the clamping is not going to allow the wires to crush down to a flatter surface, and things aren't going to clamp on as they should, and as the solder wears down, it's going to loosen up the connections and blah, blah, blah. I've talked to many people who are in the professional industry, and they do not recommend doing this under most conditions. But they also are referring to, most of the time, higher voltages, a lot high amperage, a lot higher current. Also AC, which is, alternating current, like what's in your house. These are the applications that they're not supposed to do this in. This application, where it's 12 volts of power going through a power supply into an Arduino shield and all that kind of stuff, it's really not that bad of an issue. I wouldn't say that you're never gonna have any issues doing it. Just because, for one, I'm not gonna say that because, I need to cover my butt. So you could run into issues if you do it this way. I never have. I don't know anyone who has, but you could, according to industry people. So if you do not want to tin your wires, just skip the whole little section right here. I'll put a timestamp right now of skipping the wire tinning, and I'm just gonna, after that, I show you how to correctly install the wire into the green connector thing, because the green connector is kind of stupid, so you'll see that. So skip to that point if you want. If you want to tin your wires, you can continue following this process, or if you want to just hear me tell a few stupid jokes, I'm sure I did at some point in this video. For the astute among you, you probably already have seen this video. This was on my channel a few days ago. Yeah, this was on my channel a few days ago, and I put it online, and some people were like, "Oh, you can't do that. You can't tin the wires." So I'm just clarifying that you shouldn't do it according to industry standard. It's not up to code in some things, but for this application, you probably can. But I'll leave that choice up to you. So continue on with the video.
Those of you who are good at soldering, or you've done it for a while, you know what the hell that is, and you probably already do it and haven't had issues. But those of you who have had issues, you probably didn't do this. Now, that's not to say that some other defect with this occurred and that's why it melted, but this is going to eliminate 99.9% of the issue. You just take your soldering iron, you have the the solder and everything like that. Of course, this is not how you should do it. You should have a helping hand holding this, and you should be using the solder, but basically, whatever. And you want to tin the ends. Let's see if we can get an action cam. We got an action cam. So basically you're just going to, well, look at that smoke. Don't breathe that in, by the way. And see how I'm just heating it up and just slowly letting the solder flow on. Those of you who do soldering correctly, you know how to do this correctly. The whole point is you want to cover the entire end with solder, so it looks like that. Right? Come on, you frickin' hell, focus. Well, you get the idea. It's soldered. By the way, don't hold it. My hands are on fire right now. This is not a guide on how to properly solder. This is a guide on how to not catch your house on fire. And if you know how to properly solder, you're not going to catch your house on fire, hopefully. So, you see that right there. Now it's tinned. This is what's called tinning. So now if you try to unravel this, it's not going to, because the whole thing's basically one big blob of metal now. I had the unfortunate realization that I had my camera propped up on the screwdriver that I'm using for this, because I'm an idiot. So, see that? Flat head, a tiny little one. Look at that, flat head, tiny one. That goes right into these You tighten it down, you loosen it up, whatever. Now once you have this tinned, as I said before, you want to make sure that these are actually open, because people don't do this right, okay? Let's see if I can show you this. Well, hell. If you can't see this in the picture, I'll take a picture and show you. You'll see the little tabs inside of there, and they're facing upward, or they're towards the top part of the, you know, where the screws are. You'll see the little tabs in there are up there. That means that they're closed, okay? What you need to do is open them up. Let's see if I can do this without... God, this is terrible. I'm so pissed. See that one that I'm screwing into currently? See how it's opening up? It's opening up its jaws, right? See how it's fully loose now? It opens up, alright? That means that this connector's open now. And now you want to insert it into that hole. And see how there's a little bit of wire sticking out? I don't recommend leaving that. I recommend putting it in, find where it bottoms out, cut off that amount right there. Now it's a little bit shorter. Focus, thank you. And now insert it in there. So now when you lock it down, the wire is, or the insulation on the wire is just meeting the edge. Just on the outside, preferably. And then what you want to do is tighten this fricker down. And you will be tightening the screw, and you'll also see it tightening down onto the threads. Now what you really want to do is tighten it down a lot, okay? I know my camera work isn't amazing, but seriously, this is important. Switch to a bigger bit if you need to. But you really want to crank this down. Obviously you don't want to strip anything, but you should be able to hold this connector and the piece of wire and really pull on it. And it doesn't slip out at all. Okay? If it pops out, you did it wrong, you need to tighten it more, something like that. When you tin that end, and you solder the end like I showed you, and you lock it down in there, it really gets a good pull on that. And you cannot pull this off accidentally or something like that. It's not going to pop off accidentally. And if you look in there, you should see no frayed wires or anything like that sticking out so it bumps into the other ones. You know, something like that. You do not want any loose wires or anything. Make sure that is tight as it'll go. And inside there, you know, you can't really see anything, but there's connectors in there. So just do the same thing for the rest of the wires. You need to do that. Follow the schematic for the printer. All the Folger Tech ones are the same, but you know, may vary. You know, your results may vary, but then you just stick this on right to the ramps and it should work just fine. You shouldn't have any problems with this catching on fire. Every single one that I see someone, you know, there's melted or something like that, there's just frayed wires everywhere and they just barely locked it in, or the wire came out and was touching something and it was shorting, and there you go. If you do this, you will reduce your chance of catching on fire. Like I said, strip it out about the length that you need to right here. Tin the ends with some solder so it doesn't loosen up and it's all one locked in nicely, beautifully like that. See how nice that looks? And you stick it in there, make sure the door's open. You'll see what it is. You loosen up the screw and you'll see it open up. You tighten up the screw, you'll see it tighten up. Okay, it's probably going to be closed by default, so you're going to have to loosen it before you lock anything in. And see, if you pull on it really freaking hard and it doesn't pop out, you're doing good. So, please do this correctly. This is extremely important because I don't want your shit to catch on fire. I don't want your 3D printer to catch on fire. Like I've told you guys before, I'm the tech support for Folger Tech, and you would be surprised how many people message me saying, "Oh, the thing caught on fire, it melted or whatever," and it just there's this wires sticking out everywhere and it's a rat nest. I'm like, well, that's why. It's because you didn't do it right. So please do this correctly. If you did catch something on fire and now you're trying to figure out why, this is probably why. You really want to lock this in correctly. This has a lot of current going through it, so you want to reduce the amount of whatever I'm trying to think of, resistance and any space, any gaps that are connecting to everything. You really want to reduce any variables, so it's just getting everything from the wires directly into the board, and this has the least amount of stress and heat on it, so nothing melts. I've had 3D printers, my proofs I've had for a year and a half, over a year and a half at this point, and I've never had one single issue with it. But I've seen people who have had like 4 or 5 of these connectors and melted all of them. So yes, these connectors are stupid. We at Folger Tech are actually looking into other options to avoid these connectors and maybe ramps altogether. Nothing final, nothing big right now. This is just an idea. We're looking into things because these are stupid. These aren't really that good of connectors, but you can avoid breaking things just by doing this correctly. By the way, any wires that go together, you should always tin the ends. You should never not leave it unsoldered. If you're afraid of soldering, you shouldn't be building a 3D printer. Like, it's just the sad hard truth of it. You really should be tinning the wires, soldering everything, making sure the stuff's insulated from each other, etc. It's darker because I forgot to record an outro. Yeah, so hopefully this helped. Hopefully this actually helps you guys, and please do this right. So if you found this helpful, thank you. You can comment in the bottom or subscribe or like or whatever. It's all helpful to me. Keep up with my videos. I do stuff like this, and I'll be doing other videos for other of the 3D printers, Folger Tech especially. Thank you for new subscribers, old subscribers, all you guys who support me. Found this helpful. You guys are great. Thanks to Folger Tech for providing me with 3D printers and a couple spare parts, especially this green connector. I actually didn't have an extra one, and conveniently I got sent one, so I was able to make this video. So thank you so much for everyone, and hope this helped, and until the next time, I will see y'all later.